So we're going to use this formula here to decompose our magnesium sulfate. Um, and then that's where we get this information here. So now we've got two units. And we get 2 sulfur dioxide. Uh, 2 magnesium oxide, 2 sulfur dioxide, and according to that, 1 oxygen. I thought it was 2 oxygen. It's 1 oxygen. No, that's not right. It's 2 oxygen because it says O2 on there. And we have to input carbon. Actually, no, we don't. We don't do that. That was a different process. We don't need excess CO2. So I will move all of this over here. That's splitting it. And then that will, we still need to split the sulfur dioxide, which I already have done somewhere up, or did I? That's the one that I missed. We have to split sulfur dioxide. I don't seem to have that in there, do I? So this is going to be SO2. Sulfur oxide. So we get one of those, one of these, and 2 of these. This is a sulfur. Now Why is split carbon dioxide? Oh, that's for plastics. Split magnesium oxide, split sulfur dioxide. Into sulfur and oxygen. And that takes care of splitting the magnesium sulfate. Why couldn't I make that a 1? I don't know. I guess we just leave it the way it is. Alright, now the timing. So I've got 10 units per hour of product. Now this was the splitting of the silicon dioxide. One hour product. And that was at 0.1. So I want to do 120 units of split product at 2 hours. And right now I'm getting only 10 units per hour at 0.1. So if I get 100 units in 2 hours, that would be 1.0. If I multiply it by 1.2, I'm multiplying it by 10. Why am I multiplying it by 10? See, I don't know if I'm multiplying the units or the time, you know? Everything is so screwy. Units in 1 hour. So that'd be 100 units in 1 hour. Oh, I see. That's 100 units in 1 hour. I want 100 units in 2 hours. So then what I've got to do is 0.5 should be equivalent to 50 units per See, that's 50 units per hour. Yeah, that's right. So that's about 100 units in 2 hours. I think the it took 4 hours to do, well, I fixed 4 hours to do 20 units of Martian soil. I fixed that, so that's I think I fixed it, didn't I? 5 hours per can. I think I fixed those numbers. So if I put that at 0.5, that's a splitting is 2 hours to split that stuff. That seems like an awful long time, you know what? So if I get my product, what I'm trying to do is I'm trying to get, okay, so if I got 5 hours to get 100 units of, God, I gotta open up another list. So if I look at this chart here, and I get oh, Split Mars Rock 3 is what I'm missing. I still don't have that. And I don't fucking know why. Fuck. So I put down silicon dioxide. I put down 0.2 at 20. That's 5 hours. That's 100 units. Oh, I'm picking up 2 units of Fe iron oxide for every 10 here, aren't I? Because it's 10%. So, oh fuck. So if I multiply that by 5, I'm only getting 10 units of iron oxide per day. God damn, that's not very good. That's 4 times worse than what I was originally planning on. Considering it takes 5 hours or less to process that. That's only 10 units per day of iron oxide. And I'm like 4 times short for what I need to collect this iron oxide. And that's the only way to get it out of the soil. So if it's 10 units a day on a good day, oh God. Well, considering I get those MTGs that where I can run stuff at night, maybe eventually I work my way up, you know? So, but I'm gonna say 10 units a day. And I need 800 units. That's 80 days. You might as well say 90 days of iron. That's just to build the shelter. And I'm assuming there might be 10 cans available of iron in that. I don't know how many there is in there. Maybe I gotta find out. Because I'm looking at 3 months here. Alright, so that takes care of that. So I've got to convert this to 0.5. If it's 1.0, it's 100 units in 1 hour. I wonder if I shorten these times up a little. I don't really want to. I gotta go in there. Alright, so 100 units in 1 hour. So 1.0. If I divide it by 2, it's 50 units per hour. 100 units in 10 hours. 0.5. So what I'm going to do is I'm going to change all of these numbers. To 0.5. That's for the 1 unit, right? At 0.1, I was getting 10 units per hour. So if I multiply it by 10, I get 100 units per hour, and then if I divide it by 2, I get 0.5, so... And that's based on the number of product input. So now... so this is going to be 0.25, right? Is it half of that? I think that's right. Oh yeah, this is a definite difference. Um, that should be 05. Because I got about 10, 13 up in there. That's 2.5. And this is 0.125. Actually, the plastic should take longer to make plastic, but I'm only getting... Oh, I'm splitting it. This is just splitting. And I gotta change my title. What about the sulfur dioxide? Okay, I got that in there. That all looks good. I got 2 MgOs in here. This is going to be K2O5. I'm just glancing over my everything looks good now. Alright, I like it. Now let me go back to my, this is my synthesis. I'm assuming the same numbers. Oh shit. 0.5. It's the process, it doesn't matter. Or, well, synthesis should take a little bit longer, ideally. That should be, fuck, 105. I got a problem here. That might have been sulfur dioxide. Synthesized sulfur dioxide. Possibly. And sulfur dioxide is input sulfur. Wait, this is not even there. Jesus. So, one magnesium. I don't know why the hell that's there. 1 sulfur, 2 oxygen, and 1 sulfur dioxide. And this is going to be SO2. What a way to kill time with your life. Hey, you know what? Been there, done everything in my life. I don't need anything more. Got it all, baby. Combine sulfur into, alright, this sulfur dioxide. Synthesize sulfur dioxide. Wait. Copy. Paste. 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 So all these are all one inputs. This is a 6 input. Now how do I deal with that? I've got to divide it by 6. Well, if I divide it by 5, it's 0.1. Now, it should be, that's a 2-hour processing time. Oh shit. That's not right. I gotta look at that in a minute. See, it gets more difficult down here. The highest product input is human waste. If it was 1 unit for 2 hours, it would be 0.5. Since I'm doing 4 units, if I divide it by, if I make it a 0.1, well, if I divide it by 4, it's 0.125 for 2 hours. I think that's correct. Now for this one here, if it's 10 nutrients, it's divided by 10. So to get 2 hours, it would have to be 0.05, 0.05, 0.05. I've got 4 units there. That's 0.125 for 2 hours to make plastic. Let's make this a 1. 4 units of plastic in 4 hours. Four units of plastic in 4 hours. So that's what I'm putting in there. The synthesized fabric is going to be half of that. Half of 0.12 is 0.06. So I got 2 hours of this stuff here. For the fertilizer. I'm wondering if I could go a little bit longer on making the fertilizer. If I doubled it, that would be 4 hours. And in 4 hours I could get a lot of methane in 4 hours. I think I should double these times. That's what I think I should do. Let's see. Those are 2 hours. If I double it, that's 0.025. Well, maybe to make the micronutrients, I don't need to. Micronutrients. This could be 2 hours. But this one, let's see. I'm gonna put that number in there. So that's about 4 hours. Okay, so assuming that stuff runs at night. And I think that's it. File, save. Now I just have to look at the other lists here. Let's see. 5 units. If it's 1 unit, it's 0.5. So 5 units. Wait. If it's 1.2, it's 100 units in 1 hour. 0.5 for 1. So wouldn't it be a 0.1? I think that's a 0.1. And that gets me 2 hours to make fertile soil. I think. I had another number close to 5 down here. 0.125. Yeah, that sounds good. Alright, so now I go back up here. These numbers should be okay. Now the only thing I don't have is I've got phosphorus. If I go back into the... Wait, let me look at my resource list here. I don't think phosphorus is in here. I don't think I added it yet. I did. That's phosphorus. Pentoxide. And the other thing I wanted to do is go to silicon dioxide, and I want to change the title to SO2 and the description to silicon dioxide, and see if that makes a difference on the can. If it does, I can change the title, and that hopefully that's what shows up on the can, and I can use the chemical formula maybe. I don't know. The only other thing that's missing would be sodium. I got sodium, calcium, and okay, phosphorus is not used yet. So if you go back and look at the synthesis here, um, we could actually add phosphorus now to. Oh no, I can't because I only got 3 inputs. Shit. I gotta create another. Damn. I have to create another nutrient synthesis. Fertilizer. I need to have phosphorus. I need to add phosphorus to the fertilizer is what I need to do. So what I'm going to have to do is I'm going to have to make another step here. Another nutrient step of some sort. I got a micronutrient here. Got iron. I got potassium, iron. I need to get phosphorus in there somehow. And I also need to purify the water. We need to purify the water with chlorine. I should probably add that in there. That needs to be added. I got micronutrient. Let's see. This should be called trace nutrient. Maybe. And I could Alright, so I think I know how to do this. Let's grab this. And we're gonna create, this is gonna be a trace nutrient. Wait a minute, let me think about this. Let's see. And timing changes. Trace nutrient 1. I want to have another name like trace nutrient 1 and trace nutrient 2 because I have to add. What if I put phosphorus in here instead? PHOS, phosphorus. Oh shit. So I get iron and phosphorus, and then I want to call this trace nutrient 1 or trace nutrient production. And then this is going to be trace nutrient 2. And this will have Oh, I can actually, wait, no, I've got to have trace nutrient in here. Trace nutrient 1 will go in here, and then I've got to have the Epsom salt. In the water, and then we get trace nutrient 2. And this is going to change all these numbers again now. Actually, what I could do is, let's change this to TN1. Paste. Paste. I'm just going to go down here and do this one. And this will be a 2. Alright, so we're adding iron and phosphorus and water, and we create trace nutrient 1. And then we have to input trace nutrient 1 to add the Epsom salt and water, and we get trace nutrient 2. Then we've got to add, shit, I still don't have enough inputs. I could use I've got trace nutrient. Where's the micronutrients? I got water from there. Alright, so we've got nutrients, and I should have chlorine's got to come into, well, I suppose, does chlorine have to come into this mix? Probably not. Trace nutrient 1, trace nutrient 2. Now I'm creating the fertilizer. I've got 10 nutrients. Where are the micronutrients coming from though? In other words, maybe they're created with the fertilizer. Trace nutrient 1, 2. Okay. So now we take we got alright, so this is going to be trace nutrient 2. And the nutrients, and the trace nutrients, and the water. And now we get our fertilizer. I like it. Now I'm going to save this. And everything looks grammatically correct. I've got to go to my list here, and where it says micronutrient, actually, let's see here, trace nutrient. Just grab that. So now there's no micronutrients. So we got trace nutrient 1 and trace nutrient 2. The micronutrients will be in the fertilizer. Now if we just go back here and double check this again. So we got trace nutrients 1 and 2, and then though trace nutrient 2 is added to the nutrients from the human waste, which is potassium. I'm wondering if there should be chlorine in that mix, but it's not. I guess we're not really trying to clean, but okay, trace nutrients, fertilizer. That seems to be okay. Why is this 0.05? Okay, because it takes a long time. Alright, now, let's look at chlorine. So if I go to the chart here, chlorine is at 5%. So, and that's probably in the soil. So if we go and let's see, we're going to add that to our list. Let's take a look at this again. Chlorine on Mars. Potassium is the Martian mantle is richer in potassium and phosphorus than Earth's. Fourth, the Martian crust contains higher percentage of volatile elements such as sulfur and chlorine. These minerals would help to keep brine, chlorine containing a liquid over a wide range of temperatures and has exciting implications for life on the red planet, blah blah. Sodium, potassium, ammonia, both naturally occurring metals, glands, ions, balance, blah blah. Sodium perchlorate, for instance, blah blah. Chlorinated methane compounds when soil samples were analyzed. It is certain that the chlorine came from Mars. So 5% maybe, I guess. So now let's go ahead, we'll just take we'll take calcium, I guess. Wait, let's take nickel. And then we'll add chlorine. And I'll just change that to 0. I'm changing the color definition a little. Surface. Chlorine. Okay. Now we've got chlorine. Now we go to our extraction for our soils. We've got 3 outputs. Mars core. It's going to be in the soil. Let's take out, we're going to change some things with our soil. Let's see. Let's grab this. And we'll put this one down here. we're going to call this 4. And what we'll do is we'll take out the higher levels of items. Calcium and nickel. So that one. Potassium was low. So this would be chlorine. And the numbers are already correct. At 10 it would be 0.5. So I've got actually we can do this with the small processor, I think. We've got chlorine, potassium oxide, and phosphorus pentoxide. So if we look at the chart, there's potassium oxide, phosphorus pentoxide is at 5%, and chlorine. So we've got those 3. So they're in there at 5%. Very nice. Okay, I'm going to change this to a 4. Bring this up here. Now we've got chlorine. That all looks good. Split soil into chlorine, potassium oxide, isn't it? Potassium. So we've got chlorine, potassium oxide. Some of my wording conventions isn't right. I don't care about that right now. And the numbers are correct. And we've got chlorine. We're able to extract chlorine. Now let's exit this and go back to there's no, we gotta go back to our water purification. And we can input chlorine. So let's see. Chlorine and maybe 3 units of chlorine, and now we've got purified water. Woohoo! Oh, sweet loud. That's what I'm talking about. We don't drink crappy water on Mars. We drink the good stuff. How do you like that, huh? Isn't that nice? I like it. I think it's gonna work. The only problem now is my freaking pyrite extraction. Why the frig does not work? That's my only problem right now. I don't know why it doesn't work. So what we're gonna have to do with this is I'm going to bracket out some stuff here. I'm going to bracket out this magnesium sulfate because I think that's what's causing the problem. Now what I'm going to do is I'm going to take a little break. I think I've got to go do something. Probably get some food and whatever. And we're ready to test this thing. So I'll be back in a bit.